Hey guys, I hope everyone can hear me now. So let me start the presentation. So I'm Mohan and I'm here to present ZeroLync. So ZeroLync is simply a cross-chain wallet like which lets you to do transactions on any chain. So the idea behind ZeroLync is just to have a single wallet which works on any chain. So for the first approach that I have done is using passkeys because currently, like if we want to use a single wallet on any chain, the only solution that we have for now is passkeys, which is self-custodial. There are also like other custodial options. So let me jump into the demo like first, and then we can discuss and I can explain like how it works. So yep. So let me. Okay. Hope my screen is visible. So currently we support two chains, Solana and Sui. So this is built using LaserKit SDK. So the Solana part is completely handled using LaserKit. Also the WebAuthn and passkey creation is also done by LaserKit SDK. So I'm creating, so I already have a wallet, but let me create a new one. I don't mind the error. So now we have like two wallets, one in Solana and one in Sui. The interesting thing is like both has same private key, which is passkeys. So yeah, let me make a transaction. So here, this is from a different browser. So I'm connecting my existing wallet, so which already has some balance. So I'm going to transfer from this one to my the other wallet that we just created now. Okay, so this is for Solana. So I'm going to transfer 0.1 Sol. Okay, hope it works. Yes, cancel. So you can see here. Yeah. Yep, so we have received. Wait, I think something. Okay, let me try sending again. I think it's. We'll send 0.01. Okay, I'm signing again. Yep, we have received. I think the balance API is working a bit slow. So we can see here have received the 0.1 which we sent before. Let's try sending Sui. Okay. Refresh. Yep, you can see here we have received 0.01 Sui. Okay, I think I can jump into some explanation. So, yep. So I think everyone has some basic idea about passkeys. So you might have heard some lectures and explanation from LaserKit team. So I can explain a little bit. I'm not going to go deep with passkeys here. So what are the benefits of passkeys? So phishing resistant because passkeys are tied with a single domain, and it's your private keys are technically stored in like the hardware, like hardware enclave. So it's safe. It doesn't leave your device. And yeah, you can use your Face ID, fingerprint, PIN, or even security keys like UB keys, etc. And yeah, you can also sync with iCloud, Keychain. These are like the general benefits of passkeys. And this is how the WebAuthn ecosystem works. So we will have the secure enclave. Secure enclave is a storage which is embedded into your hardware, like your Mac, your iPhone, or your Android phones. So we have public key and private key for like as usual. Yeah, and we have in the browser. So currently this works only with the browser with ZeroLync. You can also use this with your mobile devices as well, like within the application as well. So we have the WebAuthn API, which you can use to generate these passkeys, and the authenticators here are just the Touch ID, Face ID, and all the basic security features that you have in your hardware device. Yeah, let's get into the registration user flow. So this is how the user flow works. This is specifically for creating the passkeys, not for creating the wallet. So we will get into that part later. So user creates a passkey, and yeah, it's through the application like your front end. Uh, so from that we make a WebAuthn request, and it requests credential creation to authenticator, and yeah, the authenticator returns to the user. So user has to use their biometric Face ID or fingerprint, and then we generate P256 key pair. So this private key is stored into your hardware and cannot export it. And then it returns the private key along with the credential ID and other data which is required to identify your private key. So yeah, once we get the credential, we store the credential ID plus your public key in like local storage. Yeah, you get your passkey, and this is like the authentication flow. So like for signing the transaction, so when you click sign transaction, again, as usual, we go to the WebAuthn API, we request for signature, and it returns to the user where user has to use their Face ID or fingerprint. Yeah, and then sign the data is like the data, the payload is signed with the private key. Yeah, and then like we have the signature and DER format. Then yeah, the signature is validated and returned, and yeah, we can process the signature, which means the transaction in like in the case of a blockchain transaction. So I'm not going to explain these things. So this is the difference between a traditional wallet and the passkey wallet. It's just a simple differentiation, nothing like deep. So in traditional wallet, like we have seed phrases, a private key, and then we have to sign with our private key. The problem with this method is it's not a problem. If for a tech nerd or someone who is into crypto, it's not a big problem. But the problem is for the regular users, like the normal people. So you have to store this seed phrase somewhere. You have to keep these safe, probably in a hardware wallet, and probably you can lose your hardware wallet, so you have to write it somewhere. uh, Plus the other biggest problem is that now we have multiple chains, not just Solana. Like if you take EVM, there are like multiple L1 and L2s, and again we have other non-EVM L1s like Aptos, we Tron, a lot other coming up. So as a normal user, like storing keys for every chain is not like easy. So passkeys make this simple. So basically, you're just going to have one private key, which is your passkey private key, and yeah, you can create wallets on many chains. For example, in Solana, we LaserKit has done this through something called Smart Wallet. So Smart Wallet is a smart contract wallet, which is just like your normal wallet, but a smart contract function or a storage which holds your assets and everything. We also have smart wallets in EVM, but like in Sui, we don't have a smart wallet. Instead, they support it natively, but I do think like smart wallet option is better, because in case if you lose your device, there is a possibility that with your smart wallet you can assign like two uh, passkeys as your signer or your authenticator, so that even if you lose one device, you can still access your account with another one. So that's an advantage of having the passkey wallet. So these are like the signature schemes that passkeys use. I'm not going to go deep into that. So how this is how ZeroLync uses passkey. So so in, so initially we create like as a user they don't see the difference like for but in the backend, like initially we create a passkey for Solana, because since we have used LaserKit SDK, so it goes through them and we create like the private key and everything, and also the Solana smart account. And once that's done, like we trigger and create for Sui. So this is the flow. So the portal is the domain, like for create, like the passkeys are associated with a specific domain. So here in this case, we are using a domain, like a service called portal, which is again built by LaserKit. I had to modify it, like few things to make it work on Sui. So that will be hosted in IPFS or somewhere. So yes, so once the passkey is created, like your credentials, like your private credentials are stored in the enclave, and you get your public keys extracted, and these are like the flow for two chains. So we do address a derivation here for Solana, of course, since we use smart wallet. So LaserKit derives the PDA, and yeah, your smart wallet gets deployed. And for Sui, they support it natively. You don't need a smart account. So we use SIP9 passkey public key, and so in Sui we will use this flag to differentiate like the normal wallet address and the passkey address. So, and yeah, this is for the transaction signing. So we have a challenge and stuff like that. So, and yeah, I think too many diagrams. So okay, so this is the system overview, like how the entire architecture works. So how you can integrate a ZeroLync SDK. So as usual, we have the user interface for biometric authentication. And yeah, in application layer, we support React hooks. So just like LaserKit SDK. So you can just directly integrate into your React or any Next.js applications. Yep, we have the passkey storage, which is again your secure enclave, as well as the local storage for credentials and the public key. So we have Sui and Solana. So the SDK, the ZeroLync SDKs, like we have three SDK. One is the core SDK, which you will be integrating if you plan to use every supported feature of ZeroLync. Then you have to use the core one. Or if you want, like the specific for a specific chain, we do have SDKs dedicated for a chain. For example, we have ZeroLync / Solana and ZeroLync / Sui. So you can use those specific SDK in case you don't want any other chains or any other features that we are going to have in future. So, and like in the backend, we mainly use this three SDK. One is for the Sui SDK and Solana Web3.js SDK, and the important one is LaserKit, which is going to handle all the passkey creation and those things. And for Solana, currently we have the Cora Paymaster. So for Sui, we don't have any Paymaster yet, but yeah, in future we will also support Paymaster for Sui. And I can also explain the Solana wallet creation flow, which you just saw a few minutes ago during the demo. So as usual, you connect to Solana, and yep, you connect your wallet, and you will get a pop-up. and the pop-up, you say click like sign up or sign in. If it's a sign up, then you have to create a new wallet. So yeah, the you get like the prompt for Face ID and your or like any biometric authentication, and then yeah, create P56 passkey via portal. Like the portal is the domain that we will be using. Which so the reason is if passkeys are domain specific. For example, if I create a passkey, let's say on Jupyter Swap, I can use that only on Jupyter. In general, I'm speaking like if I create sign in with passkey on Radium, then I will be having a different public address, and I will be having a complete different wallet. So to overcome that, we need to use something like portal, or we can name it anything that we want. So yeah, then once we create the passkey, we return the credential ID and public ID, and then we request a sponsored wallet creation, because to create a smart wallet in Solana, uh, we need to call a function. So since as a user, when they're entering for the first time, they will not be having any funds, like any native Sol tokens to create. So we use Paymaster to create it, and then we deploy the smart wallet. We get the Solana address, and yeah, we save the credential ID and use Solana address in local storage. It's like caching. So yep, and this is for Sui. It's a bit different from Solana, because you can see we have Quora Paymaster, and we also have a smart wallet, but in Sui we don't have a smart wallet. So this flow is exactly same as above, except that in portal we derive the SIP9 address. Yes, we get the Sui address. Yep, and then we save it to the local storage. Yeah, and display the Sui wallet is ready. So this is how the wallet creation flow looks. It's just pretty straightforward. You just have to click 2 to 3 buttons, and you will have your wallet. And this is like the signing flow. So this is for Solana. So when you want to sign a transaction, this is how the user flow. This is for like the backend flow. This is what happens in the backend. As a user, it just happens in milliseconds, so they don't notice it. So you send Sol. For example, let's say we assume that we are going to send Solana native tokens. So in HAP, we have sign and send transaction instruction. We forward it to LaserKit SDK. They serialize the transaction message and open the pop-up message. Then the pop-up is from the portal. So once you approve the portal, this is what happens. So we got the signature, authenticated data, and client.json, and then we parse the DER to raw 64 bytes, and we do some math here, and then yep. So once your transaction is ready and signed, we send it for gas sponsorship, and at fee payer for like, you can use the existing Quora, or you can also run your own gas sponsorship service. Yeah, once you add the fee signature, then you submit the transaction. Like it just looks like a normal transaction flow, except the part here we are going to do all the signing and everything using the passkeys. So this is for Sui, which is exactly the same. So you click send Sui, you sign and execute. Like from the app, we make a request to ZeroLync SDK first, and then yeah, we fetch gas coins, because in Sui you need to have this additional step, like it's based on object. For example, if you have a balance, like let's say you have 10 native Sui token, then you might be having your 5 Sui tokens in one object and 5 in other object. So in case I want to send like 8, then I need to do some calculations, like to map the object together, and then I have to submit the transaction. So then we open the pop-up to sign. Yeah, once the signing is done, these steps is exactly same as in Solana, but here we have to do some additional step. For example, we need to submit or execute a transaction on Sui using this passkey. Then we need to do the BCS serialization, and then we get the final signature with no your what do I say, like 0x6 like flag and the BCS authenticator. And then yeah, we execute the transaction, and here on Sui network it verifies the signature and your transaction is done. So yeah, that's it. Okay, these are just like the basic flow and like deep dive of what I have explained before. So any questions? So also currently it's not published anywhere. So I'll be making this open source soon. So you can also host this demo website by this week. And we already have SDKs in npm. So if anyone like to try, you can just reach me out. You can ask your questions on comments where I can answer. Okay, maybe I can explain like the use case about this more. So like I mean, I can explain why I started building this. Maybe a little bit of story behind it. The, so I had this personal problem. Like I used to use multiple chain because I also build products on other chains like EVM, Aptos, and Sui. The one problem that I had is I need to have multiple private keys, which is the problem that I explained it before. So, which is not easy to, how do I say, which is not easy to manage those private keys. And the main problem is the liquidity. So the liquidity will be the second phase of ZeroLync, since now we have the wallet. So what's the problem with liquidity? Let's say I use Solana a lot for all my transaction, for receiving my payments and paying my for everything. You want to buy a coffee now, I use Solana. So but like since I use Solana, I hold most of my assets on Solana, like the stables, my investment, my trading, everything happens in Solana. But I do use other chains for different purpose, like the receiver, sometimes they don't have Solana, they accept in Ton, they accept in Sui, Aptos, or even EVM. So at this case, what we usually do is like we have to bridge the token. So I think everyone is aware of bridging process. So for Solana, I think we use wormhole, and there is other one. I'm not getting any names right now. I think there is Albridge. So the problem here is like each time you have to bridge, and also like each time you do it, there is a transaction cost for this bridging. as well as bridging takes time. So the procedure is like very complicated. Like you need to have like two wallets, and usually there are like two options in a bridge. Either you can connect both the wallet. The problem is then you need to have multiple extensions. I think now MetaMask is supporting all the even Solana, so maybe now it's easier. But before, like a few months ago, when there was Solana not supported, then you need to have two extensions and you need to connect two extensions. But usually in bridges they also have another option where you can paste your address. So I know people who pasted like the wrong address and the amount gets bridged to a different one. So basically you need to have the whole learning curve, as well as you need to have more idea on what you're doing here. So which is fine for people like us. Like we know crypto, like we know how it works. And yeah, I think most people here are like developers. We don't find, personally I don't find it as a problem. But for a normal person like who has no idea and who wants to use crypto, who just wants to use USDC to pay for uh, a coffee, they can't do all these things. Also, the other problem, when I said I pay for coffee, uh, so I use Solana, and what if the opposite person, like the seller or someone who owns a banh mi shop, if what if they want to settle in a different chain? Yeah, then we need to bridge, and then we have to send uh, the tokens and the chain that they support, which is not a good user experience. So what if we can have every token, like all your tokens in one chain? Either it can be Solana or either it can be some other chains that you wish. Personally, I would like to have everything on Solana, because yeah, I'm used to it and it's more convenient for me now. So what if we have a single wallet with, I mean, in user perspective, it's a single wallet. Like for a developer perspective, we still have multiple wallets. So when I say single wallet, it's like one single key that can control all other wallets. So let's talk about, like, let's think this in like ZeroLync's flow. So like as usual, you you connect your wallet to you don't have to connect your wallet technically. So you connect your wallet and use your passkeys, and you create like multiple accounts on Solana and Sui, Aptos, Arbitrum, Polygon, Ethereum. So as a user, we don't need to show you like all the address. We can just show Solana for you, but you still have like all other wallets which will be in background. If you wish, if the user wants to see it, they can see. And you can deposit the tokens on Solana. Let's say I deposit 1,000 USDC or here on Solana. And what if I can just use it anywhere? Like I can just go to Hyperliquid, or I can just go to, what are the other popular dexes? Like I can just go to CowSwap, which basically supports only EVM. I can go there and I can use the same passkey wallet. I can connect to it and I can trade the tokens that I have in Solana on CowSwap. So here the thing is, the user, he doesn't care about like what chain the application is running. So for him, all he knows is just Solana. So he has everything in Solana, and which he can use it on any chain. So how we can do this is, like, there is a concept which has been which is like popular for the past 1 year or more than 1 year, maybe more than that, I don't know. I just came across this term like a year ago, which is called intents. So where you can have a system, like it can be decentralized, it can also be centralized. Currently I think most platforms which are working with this intent based bridge are centralized. For example, I think CowSwap, they used to be centralized before, if I'm not wrong. When I mean centralized, they run their own solver. So where as a user, all you do is like you sign, you submit a transaction, your token get transferred into a vault which is on Solana, and there are like parties called solver. They pick your transaction and they solve it on other chain. Let's say I want to stake ETH, but I have USDC on Solana. So how do I do it? Like in a traditional way, you have to bridge your USDC from Solana network to Ethereum network. The problem here is, again, in Ethereum network, you need to have a wallet which has native ETH to pay the transaction fee, or you can use gas sponsorship there, but still. So you need to bridge your tokens, and then you need to trigger another transaction on to stake it ETH. Instead, what if you can just connect wallet like this passkey wallet? Instantly you have your Ethereum address there. You just connect and you submit or sign your transaction. Your tokens from Solana will be get locked in Solana, and then your transaction on Ethereum gets processed, and it is staked, and your address will be the signer, like your Ethereum address uh, will be the signer address on Ethereum. And uh, the person who does this for you are called solvers. So the solvers can go and claim or withdraw the tokens that you locked uh, on Solana. So I think my camera is clear. So this is the next step that I'm planning to do with ZeroLync, where not just you can create wallets, you can just move your liquidity. Like for example, this is also something done by Jupiter, if I'm not wrong. They call it JupNet, which we don't have much information about it now, but as far as what I have read in the article and in Twitter, it's a similar implementation. So instead of solver, they call it as DAO network, which is, I think they're going to use SVM for this. So so I think it will be more decentralized, if I'm not wrong. Yep. So the next step is to do like add more chains. Probably we'll be adding EVM chains, but yeah, there are a few complexity with adding EVM. Yeah, and then we'll go ahead with liquidity. Yep, that's it. Just give me a few minutes. So, okay. I think we can end the stream. Thanks for joining, and thanks to special thanks to LaserKit team, Chow K, and also Hugh and Super Team Vietnam. Thanks for giving me this opportunity. If you have any questions, or if you want to collaborate, or anyway, this will be in GitHub soon, so you can add more chains as well. So please reach out to me, and thank you all for joining. So you can follow me on Twitter. So I don't have, we can show my profile. So yeah, so you can at Mohan0799 can reach out to me on Twitter. Maybe I will keep this for a few seconds if you wish to, or you can also go to this website and can find my Telegram and LinkedIn there. Okay, thank you. We can end the stream. Thanks for joining.